We might not notice, but tremendous technology and mind-boggling science constantly surround us in the products we use every day. Behind their practical use lurk hidden histories, dramatic discoveries, and awesome experiments. They are wicked inventions. Coming up, leather jackets. We reveal how tough leather is actually cut with water. Hydraulics. We find out how fluids can generate the perfect pressure to lift gigantic loads. Chocolate. What is winnowing? We reveal the history and fascinating production process for this fantastic food. We reveal the surprising science and amazing manufacture behind these wicked inventions. From a military essential to catwalks around the world, the leather jacket really is a wicked invention. But just how were they introduced?
The first leather jackets were actually worn by German pilots during the First World War. They were quite different to the sort of more familiar motorcycle jackets that we recognise, but they were slightly longer, almost like a trench coat but in leather. And they were the very first version of leather jacket.
As time passed, we saw the leather jacket make yet another appearance in the Second World War. Sheepskin was often used as a liner to these jackets to keep the pilots warm and comfortable. Despite those in the military being the first to wear these leather jackets, many believe that the motorcycle industry played an even bigger part in its rise in popularity during the years to come.
It was quite a small, kind of fun thing. It wasn't particularly fast, so there wasn't a great need for safety on the bike.
It wasn't until we saw serious injuries from bike riding that the tailor-made motorcycle jacket was introduced.
In 1928, Irving Schott actually famously created what we now recognise as an iconic motorcycle jacket. And he nicknamed it the Perfecto, which was named after his famous brand of cigars.
As the leather jacket became more popular and spread into the music industry, we began to see a larger variety of attachments and other accessories. In the 1980s, popular music figures adopted their leather jackets to have broader shoulders and bigger collars.
So they created the off-centre zip, so from no more buttons anymore, it was all zippers, which was quite a relatively new technology at that time. It meant that motorcyclists could twist, could turn, could move, they had more flexibility.
It was towards the end of the 20th century that we saw leather jackets in fashion. Models such as Kate Moss adopted this rock and roll look, introducing the wicked invention to yet another industry. Today, leather jackets are as popular as ever, but just how are they made? Vanson are one of the few remaining leather jacket manufacturers in the United States and have decades of experience.
My name is Vander Slazen, and I had a partner when I started. His name was Jamie Goodson. So we put the VAN from Vander Slazen and the SON from Goodson together and came up with Vanson. He and I have been friends since 1968, so it was a long association.
The life of a Vanson leather jacket begins with cutting all of the patterns that will go on to form each individual component of the jacket. Here, a CNC water jet cutting machine has been loaded with the relevant information of the pattern to be cut. The machine then cuts these patterns out exactly, using high-pressure jets of water that will mark the leather. The pressure here is extremely high in order to cut the tough leather. It can blast out jets of water at a whopping 35,000 psi, or pressure per square inch. To put it into perspective, that's more than the ballistic pressure of a high-powered bullet striking a solid bulletproof object. From here, the leather is moved on to be hand-cut, using the cuts made by the water jet as a guide. This is an extremely highly skilled job, as the cutter will intuitively make sure to cut each piece in such a way that when the separate components are sewn back together, the grain of the leather will match up perfectly, giving a high-quality finish to the jacket. For this particular style of jacket, around 40 separate patterns are cut that will eventually make up the completed garment. This tool used to cut the leather hasn't changed in over 100 years, proving the traditional methods are still the best. The blade is hooked so that not too much pressure has to be applied when making cuts. This reduces pressure on the wrist and fingers when working. Other parts of the jacket can be cut out using a hydraulic press, where a cookie cutter type blade is placed on the leather, and a big hydraulic press pushes down on this blade to cut the leather to its exact shape.
Leather is much an art as a science, making leather. It's a very skilled and disciplined work, and it requires a great attention to detail, and you have to interpret the materials that come your way to understand how to work with them. So when you see people work in the shop and you see what they're doing, you might think they're so good at it that it looks easy, but it's actually quite difficult.
These finished cut components then must be marked up. At the marking up stage, each piece is matched and numbered so that they will be used to make up the same jacket throughout the production process. The craftsman will also mark out sections that need openings and pockets cut later down the line. It's a quick stop off at the embossing station next. Using a combination of heat and applied pressure, the embossing machine will permanently emboss information into the leather pieces. This includes the all-important Vanson logo as well as a serial number for the jacket. The pieces are then run through a splitting machine that thins out the edges of the leather, ready for the sewing stage. As well as a trip through the splitting machine, some pieces are also placed under a scything machine that also thins out the edges for the sewing process. Many of these leather jackets come emblazoned with branding, images and logos. Here we can see a craftsperson using templates that have been cut out on a CNC machine to fix on the relevant branding for our jacket. Of course, our jacket needs to be warm and comfortable as well as super stylish. With that in mind, the quilted lining of the jacket must be cut. This lining has a black nylon face that will be the part seen on the inside of the jacket. This nylon is stitched to a non-woven scrim material in such a way that quilted air pockets are created. These pockets are vital for insulation. The pocket openings of the jacket that have previously been cut are then glued open and reinforced using another piece of leather. At the same time, the quilted lining of the leather jacket is sewn together in our first sewing machine step. Once it has come together, it looks like a jacket made of quilt. Some of Vanson's jackets are fitted with what is known as a gun pocket, as they would traditionally be used to holster guns on the inside of the garment. With so many separate components to the jacket, different parts are being worked on simultaneously, such as gluing and sewing together the belt of the jacket, as well as beginning the sewing together of all of the components. These guys are certainly kept constantly busy. The metal snappers for the pockets are also fitted at this point. With this complete, it's all hands to the sewing machines. It takes many skilled hands and experienced sewing machine skills to build up a high-quality leather jacket, yet slowly but surely all of our separate patterns come together to form a finished jacket. And with that final stitch, the leather jacket is complete. That's one trendy, wicked invention. From excavators on building sites to the ramps in the car garage, hydraulic systems are the secret behind their powerful lifting capacity. But what are hydraulics?
When we're talking about hydraulics, we're talking about the movement of fluid to do an action. It's the specific use of channeled water in a confined system. So you're talking about moving water through pipes, moving water through flexible hoses. That's the kind of thing. If you put pressure behind that, as you put pressure into one end of the system, the water, being incompressible, will need to move to at the other end. And if the other end, of course, has something that does move, as you push in one end, you can remotely force the other end to do work.
Before we get into the actual technicalities of hydraulic systems, we first need to delve into the theory. In the mid-1600s, a French mathematician and physicist called Pascal came up with the definitive rule for using hydraulic power, called Pascal's principle, which is pressure exerted on the fluid is distributed equally throughout the fluid. Simply put, if you push a liquid at one end, it will move with equal force at the other. What Pascal realized was the design of the vessels that hold the liquid can give your system useful properties. Take a Charles water pistol. Because water is not compressible, when you squeeze on the trigger, you apply a relatively large force that moves the trigger a short distance. Because the water won't squeeze into a smaller space, it gets forced through the body of the pistol to the narrow nozzle and squirts out with less force but more speed. Pascal realised that this action in reverse could be used to lift heavy weights with relatively little effort.
A hydraulic system typically works whereby you have a small thin arm that you put pressure on that travels a long distance. That pressure in the system acts on a larger surface area further away, and that larger surface area, because it is big, requires more liquid to move it. It'll also move more slowly. However, that means you can move a larger weight with a relatively small action. This is akin to using a long lever to move something at the other end of a fulcrum a very small distance, even if it's very heavy, such as a crowbar to get doors open or to move wood. The other end reacts almost instantaneously because the water or liquid is incompressible.
Hydraulic systems are now found fulfilling many useful functions. In our cars, a hydraulic brake circuit allows a car's brakes to be applied equally on all four wheels. Airplanes use hydraulic mechanisms to operate their control panels. Hydraulic machines also provide and control motion for attractions in amusement parks, and some types of elevators use a hydraulic mechanism to power the elevator's car movements and make them stop when needed. Even apparently simple products can use hydraulics. For example, office and barber's chairs use hydraulics to make it possible for the chair to rise up or go down. Even though the name hydraulics comes from hydor, the ancient Greek term for water, the often high pressures and working conditions faced by the liquids used in hydraulic systems means that an alternative to water needs to be used.
Hydraulics actually use a mineral oil or a particular hydrocarbon-based system. This is useful because what it means is the liquid going through the system lubricates and keeps the system working well, as well as free from corrosion. If you had water inside a hydraulic system, you would have problems with the water getting too hot, getting supercritical, and when water is supercritical, which means above the temperature which it would boil, it starts to act very corrosively. Whereas a lot of the mineral oils will last at temperatures twice or three times or even higher than that, without corroding, without causing inactions, and they're also easier to bleed heat away from because they do not hold heat as well as water.
Arguably, the most visible use for hydraulics is on construction sites, where many machines utilise its power and precision. From dumper trucks to bulldozers, and on to other heavy machinery, hydraulics will be at the heart of some of their most critical operating systems, with the excavator being the most recognisable to most people. Until the 1880s, these diggers or shovels were operated by cables and chains, which meant a bone-shaking ride for the operators who used them. The introduction of a hydraulic alternative, where the arms and buckets were operated by fluid-filled cylinders and pistons, gave the diggers a more controlled feel and power, with the machine's movements cushioned by the hydraulic system's actions. So, how do these hydraulic arms work?
Hydraulic arms are quite useful in the construction industry especially. If you imagine a digger, it's got multiple joints that need to be moved, but need to be moved with precision and power. So what you do is you put pressure into a hydraulic system, you situate the arm at a point that's the easiest to move the arm, so you as far away from the actual fulcrum, and at that point the pressure in the system pushes on it. Because you can suck on a hydraulic system and you can push on a hydraulic system, and the liquid moves instantly and also precisely, you can use the hydraulics to very conveniently do digging and construction work because there's such power to move rather large amounts of material.
It is amazing to think that the principle behind a child's water pistol is powering heavy machinery all around the world, and that makes hydraulics truly a wicked invention. Can a single weight lift two others on its own? We're going to need 3 weights, 2 different size syringes and a length of plastic tubing. We take the syringes and connect the plastic tubing to their ends. We then fix the syringes in place on a frame. Next, we take some card and place 2 of the weights on the larger syringe. With the plunger extended, we place the remaining weight on top of the smaller syringe. With no external force, will the single weight be able to lift 2 of its brothers? Even though the smaller syringe has less weight on top of it than the larger syringe, the mass of the single weight begins to push the plunger down, and, as if by magic, the weights on the larger plunger begin to rise. The secret behind this seemingly impossible feat is because of pressure. As the smaller syringe has a smaller cross-section than the larger syringe, the effective pressure applied by the force of gravity from the single weight is higher than the combined mass of the other weights on the larger syringe, as it has a greater cross-section. As the pipe connects the two syringes, this means that the air from the smaller syringe is forced into the larger syringe, resulting in the larger weight being lifted into the air. This is the same principle that lurks behind hydraulics. Can a single weight lift two others on its own? Yes, it can. Wicked challenge smashed. Chocolate is enjoyed by those all over the world, but just how was it introduced?
Mankind has enjoyed chocolate for about 4,000 years, but originally not in the form we have it in today. Today we're all very familiar with the chocolate bar in its kind of solid form.
In fact, chocolate actually first became popular when it was a liquid form.
But 4,000 years ago, pre-Olympic cultures in South America were actually drinking chocolate, but in an unusual way. But what they did with chocolate was really mix it with a variety of things. So it's quite a bitter drink. You had it with vanilla, with honey, with chili.
This liquid form of chocolate was made from crushed cocoa beans. The main reason why this chocolate form was so bitter was because it did not contain sugar. The bitterness of this chocolate played such a big part that even the word chocolate is said to have come from the main word cioccolato, which actually means bitter water.
In the middle of the 19th century, a Dutchman discovered a way of how to extract the cocoa butter and the cocoa from the bean and press it and turn it into a solid. So they made cocoa powder, and then they could mix it with different kind of emulsions, with liquids and other flavours, compact it into a bar and sell it relatively cheaply.
Once we saw this solid form, Swiss manufacturers began adding milk to their chocolate and started selling it on local markets. From this, we saw the introduction of machinery that would make creating chocolate easier than ever. At the start of the 20th century, the price of chocolate dropped tremendously. It became more affordable for a growing number of middle-class consumers. The post-war period saw an even further increase in the purchase of chocolate, as the snack soon became a dietary habit for many. The turn of the millennium brought new and exciting chocolate variants. We saw the introduction of more unique flavours with nuts and fruits, but just how are they made today? Mars Chocolate, founded in Brooklyn, New York, produced these delicious chocolate treats all the way from bean to bar.
Mars Chocolate was started by brothers Rick and Michael Mars back in mid-2000s. They were part of the small batch craft makers movement in Brooklyn during that time, and they thought they'd give chocolate making a try. So they imported cocoa beans, roasted them in their oven at home, and the rest is history.
Here in their factory in London, England, we'll see exactly how it's done.
We work with a number of different farms and cooperatives around the world, places like Madagascar, Tanzania, Dominican Republic, and we import our cocoa beans direct.
Once they've received their cocoa beans from one of their specially selected cocoa farms, the beans are hand-sorted. Even though they only source the highest quality beans, the perfect chocolate bar requires extreme attention to detail.
I'd say one of the biggest challenges in making chocolate is the fact that it's an agricultural product. So you're going to get diversity in harvest, you're going to get diversity in end product based on whether there was rainfall or drought in the region in which it was grown. So every time we receive a batch of beans, we may have to slightly adjust our roasting profiles, our grinding profiles, our methods for making. Any single stage of the process can change due to the differences that you get in cocoa.
Noting the colour, aroma and the general moisture of each and every bean, the chocolate makers look out for any split or flat beans, as well as any pesky rocks and hard bits that may have slipped the net. The beans are sifted through a metal grid to remove any broken pieces, and only then are they ready for roasting. The roasting of the beans depends on their origin and also the type of chocolate being produced. A difference of even 1 minute in the roasting oven can affect the taste of the finished chocolate. On average, the cocoa beans are delicately roasted in a convection oven at 150 degrees centigrade for approximately 20 minutes. As soon as they have been roasted, they are immediately cooled to stop the roasting process. A perfectly roasted bean will crack easily when pressed and develop a deep, rich flavour. Now that our beans are roasted to perfection, it's time for the winnowing stage. Winnowing essentially removes the skin, known as the husk, from the main part of the bean, known in the trade as a nib. This is done by first cracking the beans and then passing them through a specially filtered vacuum system. This all happens in the winnowing machine. It cracks each bean carefully without crushing them. It then pulls the beans through a vacuum system that sorts each one individually. The nibs are heavier than the husk, causing the waste husk to get pulled away by the vacuum, leaving the all-important nibs ready for the next stage. These nibs contain about 50% cocoa butter and will contribute massively to the finished chocolate. It's time for the grinding process. The purpose of the grinding process is to create a smooth emulsion of cocoa solids and cocoa butters using only the nibs, sugar and friction. The weighed out cocoa nibs are slowly added to the grinder.
We operate in a very traditional way of making chocolate. So how the Mayans and Aztecs used to grind down their cocoa, they used stone, we use stone grinders.
The stones begin to spin at 45 revolutions per minute, and this speed is slowly increased to 60 revolutions per minute. The friction caused by the spinning stones will heat the ingredients to around 47 degrees centigrade. This will emulsify the fats in the cocoa butter, and sugar can then be added. Everything is left spinning for 2 to 3 days, depending on the chocolate being produced.
We can add in all of our flavours in natural form straight into the grinder stage. We don't have to add extracts or essences. We can add whole coffee beans and whole mint leaves and 100% pure rhubarb straight in with the cocoa, which means we have very punchy flavours and lots of intensity.
This chocolate is then rested for 2 to 3 days and slowly solidifies into large blocks. These blocks are wrapped in wax paper and left to rest at room temperature for 1 to 3 months. After the chocolate is aged for the required amount of time, the most technical part of the chocolate making adventure can begin. The tempering stage. A perfectly tempered bar of chocolate should be glossy, evenly coloured and firm, as well as having a crisp sounding snap when broken from the bar. Oh, and it also must be irresistibly delicious. The tempering machine produced by chocolate experts in Italy heats the chocolate to between 47 and 50 degrees centigrade. This temperature has to be extremely precise so as not to burn the chocolate. The machine then stirs the melted chocolate as it slowly cools to around 27 degrees centigrade. It is then dispensed into moulds. The chocolate maker then uses a vibrating table to evenly spread the liquid chocolate and remove any air bubbles. These finished moulds are then immediately placed into refrigerators that will cool the chocolate to 10 degrees centigrade. Once solidified, the chocolate is demoulded and ready to be wrapped. Even this stage is taken extremely seriously by the chocolate makers. They really do care about feeding our sweet tooth. After being hand-wrapped, the chocolate can be sent away to its eager customers, ready to be devoured and savoured by the world.
So we're now in 3 locations in London, Los Angeles and Brooklyn, and we make all of our chocolate bean to bar in our factories and stores open to the public for people to see.
Chocolate, one extremely tasty, wicked invention. So, there you have it, a dash through the hidden history, super science and amazing manufacture of products that you use every day but have never realised their amazing backgrounds. Leather jackets, hydraulics and chocolate. All wicked inventions.